I, okay, 32. Some of the stuff that I don't want, I'm going to erase. Right there. Okay. So let me redraw that thing for you. I'll try to do it exact the same orientation. It doesn't have to be. It has nothing to do with that. This is 100. This angle is 75. Okay, it's 75 degrees. Don't forget about that. We don't know this and we don't know that. Okay, first of all, if I wrote tangent of 75 degrees is equal to opposite, which is 100, divided by the adjacent, which is x, and therefore x equal to 100 over tangent of 75. And if you were asked to find approximate value, then you have to go and put this in your calculator. You get an approximate value. But I'm not going to do that. You can do it yourself if you want. It doesn't ask for it, so I might as well leave it like this. And then, so we got this adjacent side, we got this came out to be 100 over tan of 75. Okay. Now, if I want to get the hypotenuse, you can, for example, do sine of 75 degrees equal to the opposite, which is 100, divided by hypotenuse, and the hypotenuse, I call it y, right? Y. And therefore, y is equal to 100 over sine of 75. There's nothing wrong with this, but if you're asked to find the approximate value, then you have to use your calculator to get these things. Calculator, put down a calculator. All right, good. So let's move on to the next problem. I think I deleted that window, so let's check that. Open it up. These we have done. Okay, right here. Now it says find x rounded to one decimal place. Now obviously here you have to get an approximate value. So let's see now, we want to find the x. Okay. Now, there's two ways to do this problem. One is to recognize x is made of that piece, which I'm going to call it maybe I don't know, A, and this piece, which I'm going to call it B. Okay, so x is equal to A plus B, and my job is to find A and B, and then obviously I found x. So if you look at this right triangle, you know that the tangent of 30 degrees is opposite, which is 100, divided by the adjacent, which is A. And therefore, A is equal to 100 divided by tangent of 30 degrees. And you can put this in your calculator, but I also want to remind you that this is an important angle. You should have known what the value is, root 3 over 3. But anyway, I'll put it in the calculator. And then if you look at the other right triangle, right here, this one, okay, you're going to get B. You can write down, for example, tangent of 60 degrees, opposite, which is 100, divided by adjacent, which is B, and therefore B is equal to 100 over tangent of 60 degrees, which 100 over tangent of 60 degrees is root 3. But let's say we didn't know that. All we have to do is to put this and that in our calculator, and we get our answer. So let's do that. Let me clear these things. Okay, so we go 100. And I have a suggestion. Because those angles were in degrees, let me go and change my my mode to degrees. Instead of, well, let's see now, where is the mode? Okay, so right now my units are in, for angles in radian. I'm lazy, so I'm going to turn this thing into degrees, and then we're going to go and okay, that takes care of this. Okay, so let's go ahead and do tangent. Tangent. What was it? It was 100 over tangent. Okay, so let's clear this. So we go 100 divided by tangent of 30 degrees, close it, plus 100 divided by tangent of 60 degrees. And you get 296. What it says to one decimal point, so you round it after the first decimal point, so it's going to be 296.8. 296.8. So this is 296.8. See that? One decimal point. Okay. Let's erase this stuff. I will leave my calculator mode to degrees because this next problem also, oops, control Z. Okay, because this next problem also the angle is given in degrees, so the angles in the figure is given in degrees, so might as well leave it like this. Okay. All right. 43. Okay. 43. We don't know this x. Do we know this? Let me put some. Okay. Do I know this? No. Do I know this? No. Okay. And do I know this? No. Okay. So first, let's go to this triangle. All right. And why don't we find, for example, uh, the different ways of doing this problem, but I want to use it the fastest way, and it's not a good idea to use this red one, this red triangle. It's better to use this other one when we start. Okay, so I'm going to erase these. So I'm going to start with this triangle and find out what the missing sides are. So if you look at it, for example, in this red triangle, this is number 43, by the way. Okay, you have, say, sine of 60 degrees is opposite, which is 50, divided by hypotenuse, which we don't know. Immediately, we're going to get our z. So z is going to be 50 over sine of 60 degrees, which incidentally is 50 over, I should know what this thing is, root 3 over 2. If not, then you go into your calculator and find it approximately. As a matter of fact, yeah, so I'll just leave it like this. This is 100 over root 3. I will leave it like this. But as I said, if you don't feel comfortable, and if it says actually find it to one decimal point, it looks like this is a continuation of these problems. So it's expecting us to actually go ahead and calculate this. So let me go ahead and do that. Because it's a continuation of the other problem. It says find it to one decimal point. So 50 divided by sine of 60 degrees, and my calculator mode is still uh, on. Oh, okay. So I think this the problem is that my mode it looks like it's on. Is it on radian? I don't know. This I better check this. Oh, I thought I. In fact, the other answer may have been wrong. So enter. Oh, you know what? I did not enter it. Even the previous answer is wrong. So let's go ahead and do this, and then we go and repeat the previous problem. Uh, okay, so I forgot to press this enter. That's why it was left on radians. Okay, so let's go ahead and work this out. And I'm really sorry, I have to go and repeat this because the number that I got is probably not right. Okay, so let's finish number 43 first. Okay, so this thing came out to be, well, we have to type it. Okay, so 50 divided by sine of 60 degrees. Enter. Now we get 57.7. So if you round it to first decimal, 57.7. So you go here, 57.7. This is 57.7. So we have this Z. Now let's get the W. So W. So let's see now. We have, for example, tangent of 60 degrees. Tangent of that is opposite, which is 50, over adjacent, which is W, and therefore W is equal to 50 over tangent of 60 degrees. Okay, 50 over this guy is root 3, I know, but if you don't know it, go and do it with your calculator. So W is equal to 50 over tangent of 60. Let's go back here. 50 divided by tangent of 60, and this is going to be 28.9. So these are all approximate now, approximate 28.9. You should always, yeah, 28.9. And now that we found Z and W, we can go find X and Y in the other thing. So we go here, okay. So for example, you can say that tangent, or no, sine of sine of 65 degrees is opposite, which is Z, divided by hypotenuse, which is X. And we found what Z was. It was 57.7 divided by X. So X is equal to 57.7 over sine of 65 degrees. Okay, so let's go put that in our calculator. 57.7 divided by sine of 65. 57.7 divided by sine, is that right? Sine of 65. And X is going to be 63.7 because rounded to first digit. 63.7 is approximately 63.7. Okay, and similarly, you can find Y. Although in this problem, my guess is that when it says solve, it means find the missing thing, find the missing X, and this is the end of the road for us. Okay, now let's go ahead and do this one. Unfortunately, when I did it before, my calculator was not in degrees. I put it there, but I forgot to press the enter. So the previous problem, we have to do it. Those numbers, the number that I gave you was not right. Okay, we're down here. All right, this is what I did. I said we're going to call this thing A, and we're going to call this thing B. So X is equal to A plus B. Then I went to this one. Then I went to this, and I said sine, what did I use? I used tangent, right? Tangent of 30 degrees equal to opposite 100 over adjacent. That means A was equal to 100 over tangent of 30, remember, degrees. And then I went to the other triangle, this triangle, and I said tangent of 60 is equal to opposite, which is also 100, divided by adjacent, which is B, unknown B. And that means B is equal to 100 over tangent of 60 degrees. And X is equal to the sum of these two, 100 over tangent of 30 degrees plus 100 over tangent of 60 degrees. So now we go to the calculator. Notice that, yeah, so we just go ahead and do it here. 100 divided by tangent of 30, close the parentheses, plus 100 divided by tangent of 60. Ah, 60. There, okay. And close it, hit return, and I get 230.9. I got a different number before because my units were not actually in radians, it was degrees. 230.9. So the answer to this is 230 approximately 0.9. All right, so that takes care of this. Let's go ahead and deal with this problem. This is number 44. Okay, so it looks like we have to find this x. You may want to label some of these intermediate ones. For example, let me see. Let me call this A, and let me call this thing B. Okay. So first of all, I'm going to find for you what A is. Okay, from this triangle, we can do that. So tangent of 30 degrees is opposite, which is 5 over A, which is the adjacent, and therefore A becomes 5 over tangent of 30 degrees. Since we're going to do these problems to one decimal point, I'm not going to use root 3 over 3 here. I'm just going to leave it the way it is and plug it in. Okay, so we found A, all right, and very good. Now, the other thing is that this angle, we know what it is. This angle is 60 degrees because the sum of the angles in a triangle adds up to 80. So if you look at the big triangle here, big one meaning the one, this particular one, this is 90, this is 30, this must be 60. So from this green, the bottom green triangle, we have a sine of 60 degrees, which is opposite, which is 5 over hypotenuse, and it's x, and therefore x is equal to 5 over sine of 60 degrees. Okay, and again, we're going to put that thing in our calculator. Let's find out what x is. This is approximately 5 over sine of 60 degrees, 5 divided by sine of 60 degrees, and you're going to get 5.7. If you round it, 5.8. 5.8. Okay, so this is x is 5.8. Notice that I did not even need this. But when you start the problem, sometimes you go in a path at, it may not be necessary. So right there, 5.8. Okay, 5.8. Okay, so how many more problems is left? There's two more problems left, so we can finish it here. Okay, so let's do this one. A water tower is located 325 feet away there, okay? An observer knows that the angle of elevation to the top of the tower is 39. So angle of elevation is from the line of sight. This is the line of sight. And this is angle of depression. This is the angle of depression, okay? 25 degrees. What you want to know is how tall is the tower? So if you look at this triangle, and if I call this thing X, it is obvious that sine of 30, well, let's say sine is not going to help me because I know the horizontal distance. So tangent of 39 degrees is equal to the opposite over adjacent, 325. And if this is y, so tangent of 25 degrees is equal to opposite, which is y, over the adjacent, which is also 325. So what we need to do is to find x out of this and to find y out of that and then add them up. So let's do that. For this one, x is equal to 325 tangent of 39 and y equal to 325 tangent of 25. These are all degrees, okay? So the height of the tower is the sum of these two. You can do these separately on your calculator, or you can do it like this. 325 tangent of 39 plus 325 tangent of 25 and get your answer. So my calculator unit is still in degrees, so let's do that. 325 times tangent of 39 plus 325 times tangent, all right, tangent of 25. So this is 414. If you round it to the first decimal, it's going to be 414.8, 0.7, 414.7. So this height, yeah, is approximately 414 feet, 0.7. Okay, let's do our last problem. Get rid of this. Okay. What have we got here? Express A, B, and C. So the radius of this circle is 1. So A, B, and C, where's the C, in terms of trigonometric ratios of theta. So let's start with sine of theta. For example, if you look at this triangle, if you look at that triangle, sine of theta is opposite, which is A, over hypotenuse, which is the radius of the circle is the hypotenuse. So that means A is equal to sine theta. Needless to see, if you look at the cosine of that, D over 1, adjacent, there is the adjacent, over hypotenuse is 1, that means D is equal to cosine of theta. Okay, so we took care of A and we took care of D. If you look at this bigger triangle, the bigger triangle means this guy right there, okay, the green one that I'm drawing for you. If you look at the tangent of theta is opposite, which is B, over adjacent. Adjacent is the radius of the circle right there. Adjacent is this radius of the circle, which is 1. That means B is equal to tangent of theta. Okay, and in the same triangle, if you looked at, for example, This B is gone, right? The only thing that's left is C. There are different ways of doing C. For example, let me see. One way is to look at that uh, same triangle. Okay. Uh, same green triangle. Look at the green triangle. And if you look at secant of theta, secant of theta is, remember, it's 1 over cos theta, right? And what is the cos theta? Cos theta is, okay, this is not going to, let me see now, is this going to help me? 1 over that cosine of theta in that green triangle. Yeah, in that green triangle, cosine of theta, right there, cosine of theta, this green triangle, see that? This green triangle. The cosine of theta is opposite, which is, I'm sorry, adjacent over hypotenuse. Adjacent is 1, radius of the circle, right there. It's this. This is the adjacent. 1 divided by the hypotenuse. Hypotenuse is C, and that means C is equal to secant of theta. And you're done. Okay. I just want to double check this last one that we did. We looked at the big green triangle. Secant of theta is by definition 1 over cosine of theta. So look at that big green triangle. What is the cosine of theta? It's adjacent, which is the radius of the circle, which is 1, divided the hypotenuse, which is C, and therefore C equal to secant of theta. And that completes the